up in the corner, right? If you have to put the base in there, like on number 9, it's the one with the little box down here, okay? We have to remember that from one of our first few times. Okay, we have a couple more, right? We're going to 14. Right, on number 13 and 14, we're going to use the change of base formula from the front page, the little box that we glued on last time, to evaluate the logs, okay, the logarithms. Right, I'm going to write it down on here. Every one of these, you're going to round to the thousandths place. Which is 3 decimal places. 3 places after the decimal. All right, the reason that we have the change of base formula is because, remember I told you we can't use the log button on the calculator to evaluate the logs, right? Because it doesn't give you the base. But using the change of base formula, it's really easy, and you can use this to actually get the number. Anytime it says evaluate, you're going to have a number answer. No words in it, no log. You're going to have a number answer, right? The change of base formula is this, okay? Log base C of A, and you just do log A divided by log C. Okay, so if you have log a base of a number and then another number, just do log of this A, the big number, divided by the log of C. Okay, that's the change of base formula. It's on the front page, but I'm going to rewrite it here so I can look at it. Right, so for number 13, we're going to evaluate log base 3 of 17. And we're going to actually figure out 3 to the what power equals 17. Okay, it's going to be some sort of decimal. Using this formula, 3 would be C, 17 would be A. So when I plug it in, I'll do log 17 divided by log 3 in my calculator. All right, I'm going to use a little squiggly equals because that means approximately, because again, it's going to be decimals. But I'm just using the log button on my calculator, log 17 divided by log 3. All right, and there you go. That's what it is. 3 to the 2.5789 blah, 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 blah power equals 17. Okay, and I can even check it. Right, about 17. Again, that's why we use a squiggly equals. So this will be my answer. I need a round, 5.578. Since after the 8 is a 9, that's going to round up to 9. Okay, so my answer will be 2.579. And there I go. All right, that's all there is to it. That's all you're doing is just doing log of this divided by log of that using the calculator. All right, and we're going to do one more to show you. You can actually do it with natural logs or logs. It doesn't matter. Even if it's a log in the problem, you can use natural logs in the calculator as long as you use both natural logs. Okay, so my last problem is going to be number 14. And we'll say log base 6 of 1/10. Okay, so what I'm going to put in my calculator is log of 1/10 divided by log 6. Oops, sorry, approximately. Okay. Log 1 divided by 10 divided by log 6. And I get negative 1.285. All right, that will be my answer. Anytime it says evaluate, whole number answer. Interesting thing is you can use natural log too. As long as you use them on both, it'll give you the same answer. Right? Don't go from ln to regular log, but if you go natural log 6 What did I do wrong? I think I put too many parentheses. Hold on. There we go. Sorry, I put too many parentheses. Same thing. Okay, when I used natural logs, it still gave me the same answer. Okay, don't put it, it gives you parentheses. You don't have to type it in there already. Okay, like I did on the last time. All right, so there's my answer. All right, we're finished with our notes for today. Now you're going to go to Big Ideas, log on, and do the practice problems for properties of logs 2. Okay, use these notes to do it. If you have any scratch paper that you need to use, turn that into the sub when you're done. Okay, you must submit today, right? You don't have any more time. Submit it today. If you have free time at the end of class, maybe go back and do something else if you're missing something. Okay, I'll see y'all next class. Bye-bye.